Hey y'all, welcome back to the Intro to Backend Development Demos. Today we're going to be talking about abstractions. Specifically, we're going to be using this thing called SQLAlchemy, which is this cool Python abstraction for all the SQL stuff we've been doing. Don't know if you guys have noticed, this camera's at a really janky angle today. The lighting's really weird. That's because my normal laptop is currently being serviced. Dell sent me a new motherboard for some weird reason I don't really understand, so that's being serviced and there's nothing I can do about that. This is my old laptop, and for some godforsaken reason they put the webcam at the bottom, which makes the recording angle really gross. It may look weirdly okay right now, but when I start typing, my fingers are going to be all up in the screen, and we don't want that. So, just for this lecture, I hope you guys don't mind if I turn off my camera. It's just, it'll be better for all of us if you don't have to look at my fingers the whole time. All right, so let's get into this demo, right? Well, like I said, SQLAlchemy is this cool ORM for Python. ORM stands for Object Relational Mapper, and what does that mean? Well, essentially, if you take a Python object, it will relationally map it to some sort of database stuff. We're going to be using SQLite. We'll tell that in a bit. So in your new requirements.txt for this week, we're going to have a new dependency, /SQLAlchemy. And to initialize it and get all the SQLAlchemy stuff out of it, you want to instantiate that into DB. Well, okay, let's start building our databases, right? We're still kind of working on this task model, and this week we've decided SQL's gross, rewrite it from the ground up using ORMs, SQLAlchemy abstraction. Like I said, in SQLAlchemy, instead of tables or something like that, we get to write Python, right? Should be a lot easier to read, it'll syntax highlight much better, stuff like that. But what's the equivalent? How do we get started? Well, instead of a table, we'll probably use a class, right? That's kind of similar. Tables have these different columns that are kind of like fields in a Python class, right? Let's have a class called task. And we're going to want to inherit from db.model. If you don't know what inheritance is, it's just kind of a way of stealing some traits and saying, oh yeah, I'm related to this thing. So we're telling SQLAlchemy that, hey, look, our task is related to your definition of a model. You might think, okay, well, what's a model? SQLAlchemy has a bunch of different things in it. It has models, it has tables. Wait, Rahi, it has tables. Why aren't we using those, right? That's what we want. A model is really just kind of a more specific version of a table. You'll use a model for core information in your database. Isn't everything core? Well, yes and no, right? Maybe you have a task, and then maybe you have, I don't know, different people, right? Maybe you can have groups working on tasks, and that would be a many-to-many relationship, right? We learned last week you use join tables for many-to-many relationships. Well, a join table isn't really a model, right? It's not modeling any kind of concrete information. It's just kind of connecting these two other guys. So you would use a table for that. You'd use a model for the main information. All right, let's get back into it. Well, like before, we're going to want an ID. I told you guys columns are kind of like fields, so we just get to type ID equals. Well, now what? How do we tell it we want this to be a column? Simple. You just say db.column. That'll instantiate it as a column. Like SQL, though, we have to tell it what type we want this to be. So in this case, that'll be a db.integer. We also have to tell it it's a primary key, right? It's a lot like SQL, it's just Python instead. So that's just primary key equals true. Well, like before, we're going to want a description, right? And that's going to be another, you guessed it, db.column. This time it's going to be a db.notText. It's actually going to be string this time. You remember how SQL, for some reason, likes calling string texts and stuff like that? Yeah, SQLAlchemy fixes that janky thing, and we just get to call things strings. It's beautiful. Well, we also wanted to give it this not null constraint, right? That's what we called it in SQL. SQLAlchemy just says, okay, that just means you don't want it to be nullable, right? And finally, we want done, db.column, and this is going to be db.boolean, nullable equals false. Remember how I told you guys that you couldn't use booleans in SQLite because it didn't support that data type? Well, this just seems like a lie now, right? I'm using a boolean. SQLAlchemy is really smart. We haven't actually told it what database we're using yet, right? We're going to do that in opt.py. But if we tell it Boolean, then once we tell it what kind of database we're using, it'll figure out what to put into the database. So it'll kind of recast this. Anyways, we're going to need somebody to initialize these. We're going to want like a Python constructor, right? So that'll take in a self. We're going to do something else fancy called kwargs. And kwargs lets you take in a bunch of new parameters as a dictionary. It's really cool, and I'll show you how to put things into this when we get to app.py, but how to use it for now is self.description equals kwargs.get description, right? Because it's a dictionary. And then similarly, self.done equals kwargs.get done. Oops, stole the parentheses. Cool. We're also going to want something called a serialize method. What's that? Well, remember how before we were usually returning those Python dictionaries from functions and then kind of converting them to JSON using json.dumps? We can't just return a task object out of one of our methods, right? Because a task object isn't going to convert super nicely to JSON. So we're going to want to create a serialize method to convert the task object into a dictionary that can then be converted into a JSON. So serialize self, just return ID of self.id, description, if I could spell, of self.description, and then a done of self.done. Cool. This should clear us out, except there's one more thing we gotta do. Normally you do this at the beginning, but every table needs a table name. In this case, we're gonna call it task, right? Usually you're gonna wanna call the table name just something similar to the class name. There is a different convention though. Table names should be lowercase, right, in SQL, right? Whereas class names should be uppercase by Python convention, or Pascal case, right? If we had a new thing, we would call it like task and other words. Whereas in SQL, it would probably be task and other words, right? Snake case versus camel versus Pascal case. But anyway, so that finishes off our task model, right? It's a lot easier to read and, in my opinion, write than just the raw SQL, right? db.column, db.integer, primary key. So much easier to read. We had subtasks too, right? Let's get to work on those, right? Class subtask. This time again, we're going to inherit from db.model. And then what? We're going to want to define our table name again. Subtask, right? Remember, lowercase is convention for SQL. ID is another db.column of db.integer, primary key equals true. And, you know, subtasks also have description and done, so let's just kind of yoink that. Control-C, Control-V. Perfect. But subtasks have another thing, right? Because for each subtask, they have to be associated with one task. So we're going to want to have a column for task IDs. That's going to be db.column, db.integer. But remember how in SQL we had to tell it this was a foreign key? How are we going to do that here? We can't just say foreign key equals true, right? Because that wouldn't tell us what it's referencing. Well, SQLAlchemy's got a solution for us. Instead of that, we say db.foreign-key, and then we just tell it. The name of the table is task, and the field we're referencing is the ID field. So this needs to be lowercase, because this has to match up with the table name, right? The class name is capitalized, the table name is lowercase. Then this dot and ID is telling us which specific field. This comes straight from the object name. Right? SQLAlchemy is smart, like I said. It can figure out that this column's name is ID from the variable name. Okay. Well, like before, we're going to want another init function. It'll take in self, it'll take in kwargs, the cool thing I mentioned before. Another thing, we don't have to initialize ID, right? Because it's primary key. SQL does that for us, right? Even when we wrote SQL before, it did that for us. So we don't have to worry about that. And we can just get straight into description. Kwargs.get description. Done equals kwargs.get done. Task ID equals kwargs.get task ID. And remember, kwargs.get returns none if we weren't given this parameter, right? So then what? Well, okay, null will get stored into self.description, self.done, and self.taskID. None will try to get stored into this. But we said it couldn't be nullable, right? Nullable is false. that's going to throw a wacky SQLAlchemy error. And we're not going to want that, so we'll figure out how to address that in app.py. My favorite programming technique. Do it later. We're going to want a serialized function for subtask. Again, it's just going to return ID, self.id, description, self.description, and then done, self.done. My quotes are all sorts of inconsistent. You might say, hey, shouldn't we return the task ID? Well, we could, but the way we'll be getting subtasks is we'll really be getting a task, and it'll just kind of ferry the subtasks along for the ride. In which case, you know, it would be a little redundant to say, oh, task ID 1, its subtask has task ID 1, right? That's a little redundant, so we don't need to do that. What we do need to do, on the other hand, is tell tasks that this has a relationship with it somehow, right? We didn't need to do that in SQL, and technically we don't need to do it here, but SQLAlchemy is going to do some really nice stuff for us if we do. So if I just say subtasks equals db dot, we want to make another column in this task, right? That's just kind of wasted space, and like we mentioned before, you shouldn't have columns in the many side of a relationship. So instead, we'll just tell SQLAlchemy, hey, this has a relationship with another table, okay? That way, when we grab an object of type task, we can grab the subtasks along with it for free. We don't have to do any extra requests or anything. So it's going to be db.relationship. What are we having a relationship with? Well, subtask. Rocky, that's capital. That's not the name of the table. Yeah, SQLAlchemy does some weird stuff. Usually it's really smart and it's really great, but it does have a couple annoying things. One of them being, in this specific case, we want to reference the class name, not the table name. So the class name is subtask. I could change this table name to 1, 2, 3, 4, 5, but if the class name is still subtask, we put subtask here, capitalized. Okay, so it's going to be db.relationship with subtask, and then what? Well, you know, if we delete a task, we're going to want to have all the subtasks delete too, right? Cool, SQLAlchemy has got us covered, and actually SQL has us covered too, but we didn't cover this in the SQL section. There's this idea in SQL called cascades. And so the idea of a cascade is when you do something in a SQL, somehow affect all of its relationships. So in this case, we're actually going to want to do cascade equals delete. What does cascade equals delete do? Well, if you delete the task, also delete every single one of its subtasks. That's the idea behind cascade equals delete. I mentioned before we want to grab the subtasks along with the task for free, right? That's not in our serialize method though, so let's just quickly add that. Subtasks. Well, subtask is a list, right? What are we going to do there? Well, Python has this fun thing you can do. s.serialize for s in subtasks. And this should look kind of similar to you for loop syntax, but this is a kind of weird thing to look at if you haven't gone all the way through 11.10, or maybe you're not used to Python. All that this is saying is, for every s in subtasks, append in s.serialize to a list, right? So this list is going to be full of the serialized versions of all the subtasks. If those of you know what a map is, it's kind of like mapping s to s.serialize. All right. Well, I got that out of the way. Well, what if we wanted to assign tasks to categories? What do we do with that? Categories, maybe a task could have multiple categories. Maybe a category could have multiple tasks. What is a category? Think like, oh, this is my app dev work category, or this is my CS4450 category, because I'm taking networks right now. In that case, we've got to make a new model, right? Class category, if I can spell. There we go. Again, inherit from db.model, give it a table name. And we're going to want to grab the ID again. It's also going to have a description, so let's steal that along with it. Right, because categories are going to need something to define them. That can be the description. And, you know, maybe this will be a visual thing. Let's give it a color. Color equals db.column. Give me a string, why not? Nullable equals false. We're going to do another init method. You know, this is like all the ones we've done before. It's self.description equals quargs.get description, right? Y'all are getting into the rhythm of this. Self.color equals quargs.get color. We're going to want a serialize method, right? Return ID, self.id, description. What is that spelling? Oh boy. Self.description. No, thank you, autocomplete, for finally working. If y'all haven't noticed, this computer is also way slower than my old computer, so you guys might be seeing some lag too, and if you are, I'm so sorry about that. Okay. Well, I've made this, but maybe you guys noticed as I was writing, I never did anything to tie this to the task table. How is it supposed to know? Well, remember, this is going to be a many-to-many relationship. And from last week, we said we don't put those in the tables, we put them in a new table, a join table, right? Because that ended up being the most efficient or smart thing to do. Let's make one of those. Well, like I said at the beginning of this, we're not going to want to inherit from db.model again, right? This isn't modeling anything, it's just connecting some things. We're just going to want a table for this. So association table, or join table if you prefer, you can really call it whatever, equals db.table. And now we're just going to give it a bunch of parameters. Since this isn't a class, we're going to need to just explicitly tell it the table name. Let's just call it association. That's the first parameter to this function. The next parameters are just going to be whatever columns we have. So db.column, db.integer. And remember from Subtask how if you wanted to reference something, you had to call it foreign key, right? Oh, actually, I told you that db.column got its name from the object name, or from the field name. We don't have any fields in this, right? We're just passing things into this constructor. So we're going to need to explicitly tell it the name this time. So this will be the task ID. It'll be a db.integer, and it will grab from db.foreign key, remember from subtasks, task.id. Lowercase this time, because we're referencing the table. For foreign key, you reference the table. For relationship, you reference the class. It's weird, it's just something you gotta get used to. Comma, because we're doing parameters. This time we're gonna do the category ID, db.integer, db.foreign key, category.id. Okay, well now we need to somehow implement this, right? So let's go back down to our category table. Here it is. Let's say tasks equals, well, like before, this is a many-to-many relationship. We're not going to want to put this as an actual column. We just want to alert SQLAlchemy, hey, there's a relationship in here. Fill me in this information when I want to grab a category. So db.relationship, capital task this time. Then we have to tell it somehow to grab the association table. With that, we give it the secondary parameter. And the secondary parameter says, hey, join me using this table, right? Because we can have multiple association tables in one file if we've got a lot of models flying around. Generally bad practice to do that, but how is SQLAlchemy supposed to know, right? It lets us if we want to. So secondary is going to be association table. And then finally, we're going to want to do this thing called backpopulates equals categories. What is this going to do? Well, it's that might have to be task.category. No, that's fine. Well, what this has to do is it goes back to this task table, and then it looks for the association table to mix it together, and then finally backpopulates. So if we had a categories field in tasks, then every time we created a new category and associated it with a task, it would backpopulate the categories field. Or alternatively, if we appended to the categories field, it would create a new category in our database. Cool, so let's go and create that field, right? Because we did not write that earlier. Categories equals db.relationship. What is my typing today? I bet it's because I'm getting used to this keyboard again, because I haven't used it in half a year. Category. Secondary, again, equals association table. And this is symmetric, right? Because this is a many-to-many relationship. So we're really just doing the same thing. Backpopulates equals tasks. And this should be the name of the field in category that we're populating. All right. Well, I'd say the only thing we're missing now is to serialize categories in this, right? We did it for subtasks. Let's do it again. Categories is C dot, I was going to type cereal like the food for a second, for C in categories. And that's pretty much all of db.py done, right? We've got all the category stuff, we've got the subtask stuff, and we've got the task stuff. And with that, we can pretty much just move on to app.py. So let's do that. We're going to need to import the things we just created, right? So we're already importing db, at least in the starter code we are, which is the SQLAlchemy thing. But we're going to want to include all these tasks and models we just made. So from db, import category, subtask, task. Why that order? Generally, you want your imports to be alphabetized, just a thing. We're also going to want to be able to grab requests. So from import request, just to grab the request bodies and stuff like that. So that's great. This is just a bunch of setup for SQLAlchemy, right? You can read more about it in the docs if you want. I'll give you a brief overview right now. todo.db, name of the table. This is the last stuff we did before. Telling us, hey, we're connecting to a SQLite database. Track modifications, don't worry about that one. SQLAlchemy Echo is super cool because it's actually going to print to the console all of the SQL commands that SQLAlchemy is converting our Python code into, which is really fun to look at, I think, and hopefully you guys will have some good time playing around with that. If it gets annoying when you guys are debugging your code, though, feel free to switch it to false, right? I'm going to be leaving it on true. Finally, it initializes the application under Flask and then creates all of our tables. Great. This is the same as before, so let's get to it. Now that we've created this ORM, a lot of this becomes really easy, right? Because in this case, we can just return some sort of success response with all of the tasks, right? Well, how do we do that? Right, before we could just do like a select star from tasks. We could do something similar, but more Pythonic. So we could do task.query.all. And that's SQLAlchemy's version of select star from task. But like I said before, we're going to need to serialize this. So this is going to be t.serialize for t in that. And that's our tasks method, right? I would say that we can play around with it, but we don't have anything to play around with yet. So let's add some other stuff. For now, let's just do some similar stuff for get subtasks and get categories, just so we can show you later on how the cascading and stuff like that works. Why did I write subteam? Subtask. And then similarly, category. Then I want you to be C because I like letters matching up. Cool. So how do we create a task? Okay. Before, we would do that insert into and then commit, right? This time, what we do, well, I mean, like before, we're going to need to load the data. So body equals json.load request.data, and then we can get into some SQLAlchemy stuff, right? Because we did this using an ORM, we can just make a new object. So our new task is going to be an instance of task. And see how it's passing in quargs? We just get to tell it the kind of names of things we want. So description is going to be body.get description. And remember, if we leave this as none, it's going to throw an error, right? If body.getDescription returns none, SQLAlchemy is going to throw a fit because we said this was not nullable. So let's just give it a default value of the empty string. And then done equals, go away notification, body.get done, which should default to false, right? Look for. Okay. Well, how do we add this to the table, right? It's not going to immediately add it to the table just by creating the object. that would be, problematic for a lot of reasons. What if you were just printing some stuff and then you accidentally mess with your database along the way, etc. So, to connect to our database, we're going to talk to our database session. And all we're going to do is add to it. Add the new task to the session, please. Easy as that. That said, like before when we were working with SQL, we're going to need to commit. So in this case, it's just db.session.commit, right? You might think, hey, if we added new task, what's the point of separating off the commit? The main thing is commits are more expensive than adds are. So what's pretty common is maybe adding a bunch of things to the database at once and then committing them all at once. You want fewer commits than you want other things because it's more taxing on the database. Especially a SQLite database, which is a lot of file I/O. File I/O is notoriously slow. Okay, and then we just return a success response of new task. Remember to serialize it because we can't just return the object itself. And 201 to show that we've created something. All right, well now we can get it by the task ID. But like how? I showed you guys that we can query for all. How do I query by task? Okay, task equals task.query. In this case, we'll do a .filter by. And that's SQLAlchemy's version to kind of select where. In this case, it's filter by. So filter by ID equals task ID, right? Because we want the field ID to be equal to the task ID. And like SQL, this is going to grab us multiple rows, right? It doesn't know that there's only one thing with that ID. So we're going to tell it we want the first one. What does first do? First returns none if it can't find anything, right? It's kind of similar to get. So we can just say if task is none, return failure response, task not found, frowny face. Otherwise, we can just return a success response of task.serialize, and the default, 200 is fine. Okay, well, what about updating, right? What do we do then? This is another cool thing about how we made this Python, right? Because we can just say tasks equals task.query.filter by, right? Stick in ID equals task ID again. And now all we have to do is update it based off the things that we've seen in the request body, right? So first, let's make sure that the task exists. So if task is none, return the failure response of task not found. Double exclamation mark this time. Otherwise, we can say body equals json.loads request.data. And then we just change the task values, right? So in this case, task.description equals body.get description. But what if they didn't provide a description, then we can just leave it alone, right? So let's set its default value to be what the value was before. This way, if it doesn't have a description, it'll stay like it was. We can do the same thing for done. Body.get done, task.done. And finally, we're just going to want to db.session.commit. This time, we don't need to add anything, right? This isn't a new thing. This is the same task we had before. All we have to do is commit the changes we made to it, right? We're control-S-ing the changed file. So now let's return success response task.serialize. That's fine. Finally, delete task, right? Same stuff as last time. I'm not going to bother writing again. We get the task first to make sure it exists. Well, okay, how do we get rid of it now? Conveniently, it's just db.session.delete. Easy to remember. Delete the task. We're going to want to commit that, right? Control-S on the fact that we deleted that sheet, and then return a success response with task.serialize. But Rahi, wait. Didn't we delete it? How are we supposed to serialize something that's gone? Well, we deleted it from the database, but conveniently, we still have its data stored in this task object. So it's gone in the database, but it's here, so we can serialize that and return it. Perfect. So let's get into the subtask route. This is, pretty much the same thing as we just did, right? we're going to want to make sure that the task exists, right? Leave that there. If it's there, grab the body, right? Because subtasks have, you know, their own description and done field. JSON.loads request.data. Then we're going to want to create a new subtask, right? Similar to how we did task. New subtask equals subtask. Description equals body.get description. Again, default it to the empty string. Done. And this is in our quargs again, right? So it's going to convert this into a dictionary for us, which is super nice of it. Body.get done. False. And that is also task ID. Task ID equals task ID. This task ID is referring to the key value. This task ID is referring to this, you know, the thing we passed in. db.session.add the new subtask, and you know, exactly like before, db.session.commit. Return a success response of new subtask.serialize. Right? Almost the exact same thing as what we did for tasks. Now assigning a category, right? Well, again, make sure the task exists. Task.query.filterBy, ID equals task ID, and don't forget the dot first, right? Because otherwise you'll get this weird iterable thing. Task is not return failure response. Body equals JSON.loads request.data. And now we make a new category, right? Or do we? What if there's a category, what if we're trying to assign a category that's already there, right? We don't want to remake the category. So in this case, our criteria for a category already existing is going to be if its description is the same. So let's just grab the description from the body, right? So description equals body.get description, right? And you know, if they don't provide a description, in this case, we're going to want to throw an error just in case. So if description is none, return failure response, no description. Right? Okay. Then what we do is we can filter by again, right? Remember how we filtered by ID before? We don't have to filter by ID. We can say category equals category dot filter by description equals description. Easy. And again, we're going to want to get the first of that. Because who knows, maybe there shouldn't be, based off how we're coding this, but there theoretically could be multiple things with the same description. If category is none, which is to say, if there isn't a category like this, then we're going to want to say category equals new, not new, sorry, that's the C getting in my head, equals category. And what are its fields, right? Well, it has a description, which is going to be equal to description. It has a color, which is going to be equal to body.get color. And let's default that to purple, because I'm a big fan of purple. And then you'll say, hey, shouldn't we add this to the database now? If you'll remember, back in db.py, we wrote this backpopulate stuff. And that means if we ever add something to this categories, it'll automatically add it to the table. So instead, let's just task.categories.append category, right? And this way we're just letting SQLAlchemy do all the hard work for us. If this category doesn't exist, you're going to need to add it to the table, right? That's what backpopulating is. Populate it if it doesn't exist. If it does exist, sweet. Give it to us. Again, we're going to want a db.session.commit. And finally, return a success response of task.serialize just to check that the category was, done correctly. Cool. And that's all the code for today. So let's just quickly run that. Go away, AutoPep. Yep, thank you for activating my Ven VS Code. VS Code is not having it today. I'm relatively convinced OBS is about to crash. Aha, it loaded. Beautiful. I'm going to want to cd into for abstractions, cd into starter code, which is I think what I'm in. Yep. And then Python 3 app.py to start our thing. And look, it's even showing us, hey, this is the command I did to create the table. Right? Primary key ID, foreign key task ID references task ID, right? This is exactly what we wanted. So now let's go over to Postman and just, play with this for a bit. Okay. Let's just check what happens if we try getting the tasks. When sending a request. Cool. There's no data in the table yet. That's what we expect. Now let's try, you can see how I was playing with this before. I need to record the demo, which is kind of what I'm doing now. But let's just do that. And it should default to false on the done, so that's fine. That was a GET request. Let's post, and if I could get the route correct, I just kind of assumed I typed it in right before last time. That's not what I meant to do. Success error, false, task not found. That's because I put in a subtask route. Let's get rid of that. Oh boy, error name, subtask is not defined. This is a gross SQLAlchemy error. I think I know what happened. Subtasks equals gb.relationship. Okay, let's figure out what's going on. So, s.serialize for s in subtasks. Well, duh, because that should be self.subtasks. Things you forget when you don't code in Python for a while. Where did my serialize? This is app.py, not db.py. Here it is. Self.subtasks, self.categories, control S. Hopefully that fixes it. Restarting, beautiful. Active. Okay. So now if I go back to Postman, let's try this again. Beautiful. Why is ID equals 2? What? Okay, so I guess it made one before, right? Well, that's convenient because now I can show you guys some fun subtask cascadey stuff, right? So for now, if I just try getting all the subtasks, you'll see we don't have any. My computer's being slow right now, but data's nothing. So now, let's add a subtask to that second one. And its description can be Postman segment. Send. Cool, well that's made. And now you can see that if we get task 2, oh boy. I believe I know what I did. Control Shift this to bring us back. Okay, in success response, in get task, aha. So if we go here, we can see that I didn't actually call the serialize method, so I was trying to give it a method, right? You can't print off a method. So save that, and now it should be restarting. Error, name description is not defined. That's probably another self error. I just realized I've been in my terminal this whole time. We'll fix that. In assign category, if description is none. So assign category, description. Lovely. Okay, so now let's shift over to the Postman window, Control Shift P, and let's try You know what? Let's go back through the subtask stuff because I realized I missed that before. So let's create another task for one. This is just going to be, I don't know, fill. Because it is late, and I don't feel like thinking of an actual task name. Beautiful, and that's ID 2, and that should be subtasks. And this time we'll give them a description of moo, because it rhymes, and I like rhyming things. We can see that that worked. And if we just get all the tasks, or let's get all the subtasks first. We have these 2 subtasks, good. Now if we get all the tasks, we have this one for record demo with 1 subtask, and then foo with the subtask of moo. And now if we actually delete foo, that seems to have worked. Let's get the tasks. Lovely. And now let's get the subtasks to check if our cascade worked. The cascade worked. Moo is gone. Lovely. So now let's add a category to our first one. So task 1, category, and we want the description to be, you know, go to sleep because it is currently very late. Category has no attribute filter by. What did I do? Category dot query dot filter by. Save, go back to Postman, try it again. There we go. And now we can see that it's added the go to sleep category with the color purple. Well, what if I try adding that category to this again? Well, it doesn't add anything, right? Because we told that if the description's the same, that means it's the same thing. What if I said, please go to sleep? Well, now it adds a new category. And we can get all the categories. We have go to sleep and please go to sleep as the 2 categories right now. Those aren't good categories names. Those are really subtasks. So maybe category might be coursework. Right? Well, we saw that the cascade delete worked earlier. So if I delete task 0, will the categories go away? Oops, tasks 1, because we're 1 indexing. Come again. So that's /tasks/ the ID of the I hate when it does this. It thought I was typing too slowly. There we go. And so that deleted all of that stuff, right? And so now if we try getting all of the subtasks, we should see there are no longer any subtasks, right? Because we deleted all the main tasks and it should cascade. What about the categories? Well, those are all still here, right? We didn't set categories to delete, and we wouldn't really want them to, right? If I deleted all of my coursework, say, my course tasks, I might still want the course task category to be available for me next time I create tasks, right? Anyways, that's the demo for today. I hope you guys enjoyed it despite the weird mishaps going on today with my laptop and all that. So, you know, have a great day. Bye, y'all.